subsets. Before moving to subset, if I come to that a set, if I want you to write before moving set subset, if I want you to write A is equals to, I want you to write the roster form of for this set. X is such that x is less than 1, x is more than 2. This is how we read this as x is more than 2, less than 1, x belongs to R. Can you write a set builder form, roster form with this? Yes, any one of you? Can any of you write the roster form of this? How we write the roster form? For roster form, no, are real numbers more than 2. Yes, this is this is a null set. More than 2 and less than 1. Here this is a null set. Yes, you are right. Actually, I want to ask this one. More than 1, less than 2. Here it is null set. You are right. I want to ask this question. 1 to 2. Yes. So if I want you to write the roster form, so you are not able to write because you don't know which element is, which real number is just come after 1. Which real number is come after 1? Yes, Ahan, can you tell me? A real number coming just after 1?
1.1.
No, before 1.1 we can have 1.01.
Yes.
Even before this we have 1.001. Even before that I have this one. Even before that. Exactly. So basically we won't able to write a roster form because we don't know how to begin a set, because we don't know the number just after 1. So in case of real number, if we are supposed to write a set builder form, here we fails to write the set builder form. That's why whenever we come to real numbers, in this case we have intervals. Because in the case when your x belongs to real number, you fails to write the set in roster form. Okay, because real numbers are uncountable. You can't give a real number just after 1. You can say 1.0001 may or may be a number after 1, but 1 can give you 1.10 times 0 and then 1. So we won't able to get a number just after 1. That's why we come over the concept of intervals. Okay, over the intervals. So let me give you how the intervals work. Intervals. So whenever you need to show the set of real numbers, we always use interval. So I need to represent all the real number between 1 and 2. Between 1 and 2, that means I am not including the number 1 and 2. These circular bracket represents the open exclusion. These circular bracket represents the exclusion of the numbers. We are not including 1 and 2. But suppose I say I want to include 1 but not 2. So in that case, yes, right. So I hope now you understand why we are using intervals instead of set builder form, because here we fail to manage a roster form over the real number. Okay, that's why the concept of intervals comes when we are talking about real numbers. So here we are including 1. There in the previous one we are not including 1 and 2, but here we are including 1. This is the real number line form, real number line, and this is the interval basically. So again, number line I am plotting including all the numbers between, including 1. So interval should be closed bracket 1. Closed bracket means represent inclusion. Inclusion. This represent exclusion. 1 include till 2 open. So we are not including 2. This set represents all the real numbers in this way. Okay. So if I want to include both x1 2, so I need to include both 1 as well as 2. Right, 1 2 square brackets. And if we are talk about real number line, then here the number line is like including 1, including 2. These whole colored black balls or white balls here represents the inclusion, open ball represents the exclusion. Okay, so you need to learn both how to write interval form as well as real number line form. Okay, and these forms only comes when we talk about real numbers, not in the case of natural number, integers or whole numbers. Okay, or you can say when it comes to rational numbers also. So now we come to subsets. So all these intervals, why I first make you learn about these number line before subset. So if you understand or you are getting the point of intervals, you can understand the part subsets. These small intervals are part of your number line. So all these small intervals are subset of real number, because we are capturing these intervals from the real number line, not from some other line. So this is one set, this is another set, this is another set, this is another set. So there are infinite number of subsets which itself form a set. Okay, which itself form a set. So if I come to the formal definition of subsets, formal definition, a set made up of using another set, a set called subset made up of using elements of other set, using elements of other set called superset. See, here we have two concepts, subset and superset. A set which we are building using the elements of some other set. So the set we are building or forming is subset, from which we are forming this is called a superset. For example, I have a set, both are sets no doubt, but which one is superset, which one is subset, you need to decide. Suppose I have a subset this, and I need to form some other set using these elements, say set B 3 4 5, say C 1 3 6. So these two sets B and C are subset of A, and for these two sets A is called a superset. So B is a subset of A. Subset के लिए this is the notation. This is the notation for subset. C is a subset of A. C is a subset of A. So here A is your superset. A is your superset. Okay. And B and C are your subsets. If I go further about subsets, how many subsets we can form from a set? So let me tell you one more thing before coming forward. Cardinality of a set. What we understand by cardinality?
A number expressing quantity.
Yeah, basically it's a number of distinct element present in a set, present in a set, number of distinct element present in a set. So if I come to A, the notation we are using, notation NA, NB, NC, we need to keep a set which we are talking about. So if we need to find the cardinality of set A, so we write NA. This is 1, 2, 3, 6. The cardinality of set A is 6, cardinality of set B is 3, cardinality of set C is 3. So in this way we write the cardinality of any set. First of all, we need to take distinct element. If some elements are repeat, so we have to ignore the repetition before taking to the final count. Okay. So this is the cardinality. Why I Hanji? No, उसके लिए बताएंगे कैसे लिखेंगे, ठीक है, अभी बताते हैं. These are the cardinality of finite sets. Okay, whenever we talk about cardinality, it's only for the finite set. It's only for the finite set. Keep in a bracket finite set. We won't able to find the cardinality of infinite set. Obviously, if you want me to write the cardinality of real number, I won't able to write the cardinality of real number. I won't able to write the cardinality of rationals, irrationals, naturals and all. Okay. So we can write the cardinality only in the case of finite set. So the formula that I want to tell you here is number of subsets of set A. Whatever set I have, if I want to count how many subsets I can build over a set. So here we have a formula 2 raised to power number of elements in a set. 2 raised to power number of elements in a set. So let me discuss an example with you. Example, suppose I have a set E as 2, 3, 7, 11, any random set I have taken here, and I want to count how many subsets I can build, number of subsets I can build using this set. 2 raised to power 4, 16 subsets बच्चों, 16 subsets I can build. These subsets include two obvious subsets. Empty is a subset of each and every set. Set itself. When I say factors of a number, 1 and number itself is always a factor. Likewise, same here, a set itself and empty is always a subset. Then after we have singletons consisting a single element. These are singleton sets. Then we have elements with 2 sets. Generally we call them as doublets. 2, 3, 3, 7, 7, 11, 11, 2, 11, 2, 11, 3, 11, 3 हो गया, 7, 3, 7, 2. In this way, 1, 2, 3, 4, 5, 6. Then we have triplets. Triplets may we need to keep 3 elements. Likewise, we can form 16 different subsets. 16 different. Sorry, बच्चे.
Singleton elements like 2, 3, 7 and 11.
These are the singleton. Okay, these are the doublets. Few more subsets are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 we have already built. 2 more are left. So 16, 2, 3, 16, not 16. This is 6 basically. 16. It's 11 basically. 11, 12, 3. And the last one is 3, 7, 2, 7, 11. Now all 16 subsets are there. Okay, all 16 subsets are there. One more definition you need to learn: proper subsets. What is the difference between proper subset and the subset? Yes, Harish, can you tell me?
If a set is not equal to another set, then it is proper set.
Yes.
If a
Yes.
set is equal to another set, it is improper set.
Yes. Number of proper subsets. How many proper subsets we can have? Number of proper subsets. Total, out of total set I need to remove one. Which one I am removing? The set itself. Whenever we talk about proper subsets, we are not supposed to take a set itself as a subset. Okay. So the set which we are removing from here is basically this set. This set E. So the set we are removing from here is set E. So total count for proper subsets are 15. Okay. And if we need to write all the proper subsets, we need to copy all the subset except E. Okay. So let me get you to the another concept toward this power set. What is power set? Power set is basically a set of subsets. As we are talking about subsets, so if I keep all these subsets in a single set, that set becomes a power set. Yes. If I keep all these 16 subsets in a set, the notation for power set is PA. This is the notation. So if I am talking, or if I am asking for find PA, that means I am asking for power set. A set consists all the subsets, not proper subsets, all the subsets. So we just need to keep curly brackets in the beginning and curly brackets at the end. So all these subsets, when keep in a bracket, curly brackets, will become a set of power set. Is that fine? This is power set, and
These 2, 7, 11 belongs to P of A.
yes, you are right. So here we can say set can consist set also. That means an element of a set can be a set also, because here we are looking to set 2 belongs to power set A. So here the element which belongs to this set is a set itself. So 2, 7, 11 belongs to power set of A. Okay. So if I say is 2 belongs to power set of A? No. 2 is not a power element of power set A. 2 belongs to A but not power set of A. Okay. So sets can also be a part of a set as an element. Is that right? So at the end, can I write number of elements in power set is same as the number of elements in the is same as the number of subsets? Can I write this? Number of elements in power set is same as the number of subsets. Yes, Harish.
I think no.
No, we can, because what we are keeping in a set, we are keeping the subsets only. So the number of elements power set can have is only the number of subsets. So we can very well write this one. Okay. Number of elements in power set of A is same as the number of subsets, because all the subsets going to be the part of the element of this set. Is that fine? Ahan, is this clear to you?
Yes,
Okay. So now let me take you towards the question. I hope all this theory part is clear to both of you. Okay. So let me take you towards an example which we get more understand with the concept of subsets. Say I have a set in this way. So how many elements this set have? First part is how many elements this set have. Yes, how many? 5. So Harish said 5. Yes, Ahan. What you say? How many elements we have in this set?
Ma'am, 5.
5. Yes, 5. 5 is the correct one because the elements are basically those which are separated by commas. So this is the first element, this is the second element, and set 2 comma 3, as I just said, a set can also be a part as an element in a set. So set 2 3 is an element, 5 is an element, empty is also an element of this set. So 5 elements in total we have. Second question says number of subsets. 2 raised to power 5, that means 32 subsets we're gonna have in this particular question for this particular set, right? And if I ask you number of elements in power set of A, this is same as 2 raised to power 5, which is 32, same. Okay, so now you have to give me the fill-ups. You need to give me the fill-ups. Fill the blanks with belong, subset, not belong, subset, or not a subset. Okay, you need to give me the fill-ups. A part. 2 comma 3 is a subset of A. Is this true? Oh, sorry. I just need to keep it blank. You need to give me the answer for this blank. What should be the correct answer? This, or this? You have 4 options.
Ma'am, belongs to.
Belongs to. Yes, Harish.
Yes, ma'am, belongs to.
Here we can have both 2 options. Both the option work. If a student like this is correct, and if a student like for 2 comma 3, this is a subset also. You can check. For this particular example, 2 comma 3 is a subset also because 2 and 3 both are part of the set. So here both the options are correct. So this type of question can be asked in MCQ. What should be the appropriate answer? Belongs this, both this, or not, none of these? So we can write both belong and subset. So this can be asked in this way also. Okay, so B part empty A, empty.
Belongs to.
Again we have 2 options. Empty is always a subset of. We have 2 options. Belongs is the correct one. दोनों, yes, दोनों हो सकते हैं. Empty can be a subset also. Empty also belong as it's a part of a set. So next one is set 5 comma 3. What should I write?
Belongs to and a subset.
What?
No, ma'am, does not belong.
We can't talk about belong because this is a set and this is no more a part of this set. Here this is a set and this is not a subset of A. Now you are not supposed to write belongs or not belongs. Okay, is this clear? Yeah, you can write, but this should be the appropriate answer because whenever we have a set we always talk about subset. Okay, for this particular, yes, only that time we need to write belong or don't belong, otherwise not. Okay, like if I give you 2 comma 3, sorry 2 comma 1. So this is not a subset of A. You are supposed to write only subset or set. Belong के लिए you are not supposed to use belong to or not belong to symbol. वो आपके लिए directly the question will give you 2 comma 3. 2 comma 3 belongs to, that time it will be fine because that is an element. Otherwise you are not supposed to use this word, this symbol basically. Okay. So I hope the concept is very much clear to all of you about sets, subsets and sets, right? One more thing I want to notify you about subsets. Universal set basically. What is universal set? Basically universal set works as a superset also. Superset or universal set are same thing. Let me take you towards the definition of universal set. Universal set. A set is called universal only if all the elements of given sets belongs to universal to that set. See, what's the definition, what's the difference behind there is a minor difference between superset and universal set. In some cases superset becomes universal set. Look at the example. If I say 1 is a subset of 1 comma 3, which is a subset of 1 comma 2 comma 3, which is a subset of 1 2 3 4, right? Here I give you chain. This is superset for this, right? This is superset for this. This is superset for this. So the one which is superset for all the subsets is universe. Okay. So universal set is the set only. All the elements of given set belongs to that set. If all the elements of the given set belong to that set is called universal set, because superset is this one also, but universal is unique. Universal set is always unique. Superset can be one or more sets. Is that fine? So in this example you can clearly understand the difference between the superset as well as the universal set. One is the subset. This is also a subset for this set. So here this is super, this is sub, this is super, this is sub, but for all these this is the universal set, right? So after this we have just done with the topic of subsets and all, and then after it comes to Venn diagram. Okay, just a moment.